choice. So, lesson summary, scale. So a scale is a ratio that compares the distance on a map to the actual distance. So for example, in this one, they're telling you that this distance right here, right, 1 unit on this, right, on this grid is being compared to the actual distance. In real life, one unit here, it is equal to 30,000 kilometers. So let's say we wanted to measure the distance here, the diameter of this planet, Jupiter. Well, according to this, it's about 1, 2, 3, 4.5 units, right? 4.5 units this way. So every unit is equal to 30,000 kilometers. So all we have to do is take 4.5 and multiply that by 30,000, right? Because everything. So if you think about it, let me just draw 4.5 here. Let me just do a better job here, right? So 4.5. That's 1 unit right here, right? 2, 3, 4.5. So the first unit, right? So every unit, so we can say that this unit is 30,000. This unit here is another 30,000. This unit here is 30,000. That one's also another full unit, 30,000. But the last one is half a unit, right? It's not a full unit. So what's half of 30,000? 15,000. So you can either do it that way and add 30 plus 30 plus 30 plus 30, which is 120 plus 15, 135,000 kilometers, right? So it's 4.5 units this way on the grid, which in real life, it's equivalent to 135,000 kilometers. Or you could have just multiplied 4.5 times 30,000, right? So it's the ratio of the distance, right, on your map to the actual distance in real life. Let's see. So you had a few here to do. So in this one, it's saying that on the grid, every unit, right, so this distance right here, so we can write it, 1 unit on that grid is equal to how many? It's equal to 50 meters. So if you look at this Britain Tower, and if you are measuring the height, that's 1 unit right here, 2, 3, 4. It's 4 units high. So we can do 4 units times, and each unit is 50, so we can just multiply it by 50. And we get that it's 200 meters. Okay. Let's keep that there. And the Eiffel Tower, let's count the number of units. The height is, well, here's 0, 1 unit, 2 units, 3 units, 4 units, 5 units. Well, it's not exactly 6 because it doesn't reach 6, so that looks like a 5.9 units. So I can take 5.9 and multiply that by 50 because every unit is 50. So 295 meters, about. The Willis Tower, oops. Well, let's count the number of units, right? So it's 1, 2, 3, 4, 5, 6, 7, 8. All the way up there, it'd be 9, but it doesn't reach 9. So it looks like 8.5. I can't. 8.5 units tall. Each unit is 50, so again, 8.5 times 50, 425, about, approx, right? The CN Tower, which is in Toronto, 1 unit, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you can go back by 50, 0, 50, 100, 150, 200, 250, right? You can do that. Or just count the total number of units. So I forgot 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's 11 units tall. And if you multiply that by 50, we get 550 meters. So that's scale, right? The scale is comparing the distance here, this distance on the grid, and it's saying that this distance on the grid is equal to 50 meters in real life. Same thing here, right? We're measuring the wingspan. So we have 1 unit, 2 units, 3, 4, 5, 6, 7, 8. It's 8 units, the width, right? So the width. So again, we can say that 1 unit is 5 feet. So if you had 8 units, all you would do is 8 units times 5, and you get that the width would be 40 feet. The height of the plane, well, the height is 0. That'd be 1 unit, 2 units, and 2.5. We can say 2.5. It's about 2.5. 2.5, multiply that by 5. And that'd be 12.5 would be the height of the plane. All right, so again, what is the scale here? The scale says that every 1 unit on this grid is equal to 5 feet in real life. Here's something more familiar, maybe the blueprint of a house, an apartment, or a room, a floor. And we're looking at Ada's room. And it says here that every unit here on this map, every unit in this map is relayed, it's equal to 3 feet. So the length, let's see, Ada's room, well, the length is this right here, right, from here to here. And if you count the units, it's 1, 2, 3, 4, 5. There's 5 units lengthwise, and each unit is 3, so if you multiply that by 3, we get 15 feet, and that's how they got this number. What about the width? Well, the width would be, starting from here, 1, 2, 3 units. So 3 units high times 3 would be 9 feet. So going up would be 9 feet. Evan's room, it's a square, so if you just measure this, we'll get all the sides. So Evan's room, if you count, that's 1 unit, 2 units, 3 units, 4 units, right? This is 4 units on the grid. But in real life, what does that represent? Well, 4 units, and every unit is 3, so just multiply 4 times 3, we get that it's 12 feet long in real life. So it's 12, and because it's a square, everything else also would be 12. Practice. Okay, so you would have a ruler or something to measure. So there's a scale right here. They're saying that this distance on the map, this distance right here, this distance, is equal to 150 feet in real life. So let me see if I can get a ruler, because then I'll be able to move it. No, not that one. Right, so I'm making that line. Hopefully that's about the same. Right, it's about the same, right? So if I took that, that particular distance is 100 feet, 150 feet. So let me see if I can turn this. How do I turn this? So let's just, did I make it longer? No, I hope I didn't make it longer. Oh no, maybe I did. Alright, so let's take that. So basically, because I don't know. Alright, so that's about the same size, about. So if you think about it, I'm going to put it over here. Every time you measure that particular length, it's equal 150 feet. So I'm going to write it over here. That's 150. If I can get another one. So I'm going to mark it here. So from there to here, that's 1 unit. I'll move this guy down. Right, that's another 150. Now make a line again. That's another 150. See if I can move it again. I can move this guy over here. So that's another 150. Right, so I'll make it over here. 150 feet. And I'll move it again. And notice that it's not the full one, right? So we can sort of estimate here that the last piece, it's too much, right? It's about, change colors, so it doesn't go all the way, so it's about here, right? So it's 150 feet, 150 feet, 150 feet, and the last one, instead of being 100 feet, it goes up to, let's say, about here, right? Because a little bit more than half. A half would be 75, so let's say plus 90, so the last little bit would be about 90 feet. And you can add them up. 450 plus 90, about 450 feet. So, and that's one way of doing it. Okay. Hopefully we'll be using proportions, but they haven't shown us proportions yet, so I'm not gonna go there. So this one, complete the table so the two values in each row are related by the same ratio. Well, how did 3 become 12? What is the scale that they use? Well, times 4. So everything going that way will be times 4 times 4. So 3 times 4 is 12. 1.5 times 4 is 6. 4 times 4 is 12. But this one, if going bigger, was 4. Right, going this way would be multiplied by the reciprocal of 4, which is 1/4. Right, so 1 times 1/4 is just 1/4. Last one. Last one is a little bit challenging. Well, not too challenging. But it goes back to what we did not too long ago, by the way. And let me write scale factor here. And then I'm going to write area. Right, the original area. Area, scale factor. But the original area is what? What are they telling? That the original, this triangle here has an area of 72. Okay. And that then they used, so they made this triangle bigger, right? And they're saying that this, oh, sorry. Let's start again. I misread this. So Tamiya created a scale copy of triangle A with an area of 72 square units. So this is the original. So that's the original. So the original triangle has what area? Well, I hope you guys remember that the area of a triangle is what? Base times height divided by 2. So this particular triangle has a base of 3. The height is also 3. And we divide by 2. So base times height is 9 divided by 2 is 4.5. So the original area is 4.5 units squared. Somebody took this, took a scale factor of, we don't know yet, right? Increased it, made a big triangle. And the area of the scaled copy of this one is now 72 square units. Right, so what's the scale factor? What did they increase the dimensions of this triangle, right? So what did they increase the dimensions of this triangle to eventually create a triangle that has an area of 72 square units? That's the question. So remember that little formula we got by noticing what happens. Remember, it's scale factor to the second power times the original area gave us the area of the new shape. So the original area here was 4.5. And the new area is 72. And then scale factor to the second power. I don't want to get into this, but let's see if we can do this without so, well, might as well learn it right now. So what we're going to do is divide both sides by 4.5. So we get scale factor to the second power. 4.5 times divided by 4.5 simplifies to 1. 72 divided by 4.5 is 16. What number to the second power is 16? Well, there's two numbers actually, positive 4 and negative 4. But for our intents and purposes, because the scale factor can't be negative here, the answer is 4. So if you think about what this says, scale factor to the second power 16, what number to the second power 16? It would be 4. So the scale factor that was used to create this triangle, the bigger triangle, right, so that it has an area of 72 was 4. And that is the answer. To number 8 actually. How many times greater is the area of the scale copy compared to the area of triangle A? Well, 72 and 4.5 is 16 times bigger. Okay? And that's that. Is there more?